Hi, this is Inflectra, Alexei speaking. New Rapise 6.1 is out. Let's go through new awesome features available in this release. And first we're going to talk about Preamble. Preamble is a synonym to introduction, preliminary, or preparatory part. Script Preamble consists of variables and maps situated in the beginning of the given RVL sheet. Script Preamble ends where the first action, loop, or break statement appears. The feature of Script Preamble is that it is executed always. Whenever you use play this sheet to execute the whole sheet, or play selection to execute single statement, or play from here to execute the rest of the Script Preamble will be also executed. So any variable defined in the Script Preamble may be referred, and the statement will stay valid and will play. For example, in this case, the statement refers to a variable, and if we just play it using play selection, its value will be defined, so it will work properly. The intention for the Script Preamble is to make your script more maintainable, because you may easily call any piece of it and see how it works. Variable default values. Default value is optional thing. It contains the value that you want the variable to have if its value is undefined at this point. So we expect that password is defined elsewhere. It's read, for example, from some encrypted location. And in this case, default value is ignored and the password will be used for further statements. However, we want this piece of script to be executable alone, so we define some default value for this password variable. So it's assigned for the case we just play this piece alone using play this sheet or any statement inside. And this is kind of temporary or replacement password that is used because it's defined in the default value. Again, the goal of this to make every piece of the script executable without other pieces of the script. Moving on to passing values between RL sheets. Passing values between sheets is essential for making test frameworks. For example, we have a sheet here with two variables defined in the preamble, user and password. So if we use this sheet alone or execute it from here, it will use default values defined here. However, we want this sheet to be reentrable with different values for user and password. The following syntax allows that. So doPlaySheet and doPlayScript allow to have extended parameters. Extended parameters is everything going after all default parameters defined for this function. For example, doPlaySheet has just one parameter which is default, it's sheet name. So everything passed after that is assumed to be default value for a variable. So if name is equal user and there is something defined, then this would be used instead of def user here when this sheet is executed from here. You may specify value for one or more of these input parameters. So any of those may be specified or ignored. For example, let me do the same for doPlayScript, which is similar to doPlaySheet. doPlayScript, it has script path and additional parameter sheet name. So I need to specify all these values. The script path is main, sheet name is the same, so I specified all required parameters, and now everything I specify here will be passed as a variable value. So I want to only change password, for example. So I need to assign variable name here to the parameter name, so it should be exactly password. type string, different password. Well, so if I execute this statement, it will assign value ext user and ext password. And if I execute this statement, it should only reassign the password. So you see it's def user and different password. And the same applies to maps. It's common that you use maps for data-driven tests. And it's common requirement that you want to specify different map data for some real-life scenarios. So, for example, we have here a map defined in the preamble and used inside the loop for outputting data. We want to use different map values instead of these ones when calling this sheet. That's possible uh, by using external params for the doplay sheet. Just like we did with passing variables, we need to specify external params, specify the name of map that should receive values. In this case, the name is user logins, and the value that it will receive. The value in this case an expression and name of the map containing values. The name of the map defined here. So it may be map which has rows type and defining values right here, or it may be the map of range type that reads values from external Excel file. It's all the same. So we use these values, pass them inside as new version of user logins map. So login executed this way will use, instead of these values, values from here. So let me show you how it works. This is how it works when we execute just this sheet and use the default map. You see that it uses user1 and password1 only in the loop. User1 and password1 are from the default map. Now I'm executing external sheet that is going to pass new map value. You see it uses whole bunch of password and user pairs defined in this map. Headless execution may be performed in parallel with targets like Selenium Grid. In this example, we have a login subtest. It is here and it is doing simple login logic, taking three variables as input parameters: login, password, and name. Variables are global. We use these variable values for actual test execution. Global variables are essential for the case of parallel execution because global variables will receive input values. Parallel execution is done by this parent test, which is calling subtest and passing information about threads, which is a map. Threads map defines thread IDs in the first column and values for global variables in further columns. So each executing thread will have its own set of values passed in. In addition to two required parameters, test path and threads map, do playtest parallel accepts external params that are treated as values for global variables. So in this case, all executing threads will have gbrowser library variable have this value. We use Selenium Grid. We should use headless execution if we want to have several browser tests executing in parallel. Now let's see what happens when we play this test. You see parallel execution console opens and it lists the threads that are currently executing. We see thread ID and execution status. They all play in parallel. First done, second done, and third one is about to be done. Once execution is done, we have a report where all statements and report lines belonging to different threads have different thread column set. It's more convenient to use hierarchical mode for parallel execution. So we have test for first user, second user, and third user separated. So we may now expand each of them and see execution status. And parallel thread may be multi-layered or nested. Here we have even more sophisticated case. This is a test with 4 sheets. We want this sheet, call user sheet in 2 threads, and each of user sheet calls logins sheet in 3 threads. So it should have root thread, 2 more threads, and 3 plus 3, 6 more threads. 9 threads in total. Okay, so the root thread is created using do playtest parallel, and we pass names of browser profiles. So each of users sheet has its own browser profile, Firefox and Chrome. We use do playtest parallel. We pass this threads map, and we pass 2 more parameters which are needed to execute the same test but different sheet. So it's RL special entry point, it's built-in entry point that knows that it may execute different tab, different sheet, and the sheet name is users. So this is what will be executed for each thread. In the users we have the same picture, the map with threads. Each thread has login data, and do playtest parallel to execute login in each login in its own thread. The map is last default parameter, and then 3 extended parameters. One is browser library, and we pass value browser profile. This is the trick needed to pass the browser library passed inside this test further in the code test. So if this thread is executed for Chrome, this way we will say that the thread that we execute will also use Chrome or Firefox, depending on what it's called. And 2 last parameters, again, a trick to execute specific sheet. So the test overall calls itself in the itself 2 times or in 2 nesting labels. So in total we have 9 threads, and we have 6 login operations being performed in parallel. So let me just play it and let's see how it looks. So here we have a root thread that's going to create 2 more executions happening in parallel. So we have 3 parallel execution windows. So one is for creating Firefox and Chrome. This is 3 logins in Firefox, and these are 3 logins in Chrome. Waiting a bit for this to be done. The execution is performed in the remote Selenium grid, running under Azure, Windows Azure, or Microsoft Azure. That's it. Execution done. Again, when we talk about parallel, it's better to use hierarchical display. So this is Chrome, Firefox and Chrome threads. We may expand each of them, see Firefox librarian, Firefox administrator, Firefox borrower, so 3 more threads for each user. And here are operations performed for each of them. And final feature for today is uploading files to REST services. Now there is support for multi-part form data requests. Such requests are used to upload files into REST entry points, and we have special syntax for that. For example, here we have an entry point. So if content type is equal to multi-part form data, then Rapise expects that the request itself has special form as listed here. This is also described in the documentation in more details. In this video, we will just show that this kind of request sends a file specified by location to the remote rep entry point. This location may be hard-coded or specified as a file parameter, as it's shown here, as well as any other multi-part parameter. And this way parameter may be specified here and passed into the request. If you generate a JavaScript logic from this request, you may then use any files to pass into the service entry point. So you may upload images and the file data to the web services that require it.